7 stars show signs of activity from advanced extraterrestrial civilizations. This sensational news was published by scientists who used the James Webb Space Telescope to search for Dyson spheres in the universe. These 7 stars exhibited such unusual infrared radiation that the probability of the existence of Dyson spheres there has increased dramatically. The strange darkening observed around these stars cannot be explained by known natural phenomena. But have aliens really built gigantic power stations around stars, or is there another explanation? Scientists are certain that these 7 stars show such striking structures that they fit perfectly into the Dyson sphere scheme. Dyson spheres are hypothetical megastructures that advanced civilizations could build around their home star to harness all of the star's energy. This type of energy generation characterizes Class II species. The idea of such civilizations goes back to the Russian researcher Nikolai Kardashev, who divided potentially intelligent extraterrestrial races into 3 classes. The more advanced a species is, the more sophisticated its energy generation systems are. The physicist Freeman Dyson expanded Kardashev's theory and suggested that such power plants could completely or partially enclose the star and absorb its energy or radiate it as heat. This energy could then be used by a civilization to power its advanced technologies and needs. Dyson spheres have long been purely hypothetical assumptions, but in recent years researchers have found more and more evidence that they really do exist. Some unexplained phenomena in the universe point specifically to the existence of such power plants around KIC 8462852, also known as Tabby's star. Such a sphere was suspected until the eclipse was officially classified as a dust cloud. Some researchers even speculate that the gigantic voids in the universe are not real empty spaces but have been deliberately shielded by extraterrestrial civilizations in order to divert the energy of entire galaxies for specific purposes. This would then be an indication of a Class III species that can theoretically use the entire universe as a power plant. Of course, researchers are now also using the advanced capabilities of the James Webb Space Telescope to unravel the mystery of Dyson spheres in the universe. They found 7 suspicious stars with suspicious darkness in space. It sounds crazy to search the universe for dimmed or even invisible stars. Theoretically, Dyson spheres can cause both anomalies. They can eclipse a star periodically or completely. Theoretically, Type II civilizations could use their own star as a power plant, or Type III civilizations could also dim other stars in the universe to secure their energy. Scientists are therefore focusing their search on stars with inexplicable dimming phenomena and anomalies in the spacetime structure that betray stars that are present but not visible. An international study has shown that a large number of stars have disappeared from star catalogs in the last 100 years, others have appeared as if from nowhere. Here, too, the alien hunters set out in search of evidence for Dyson spheres. The phenomenon of stars disappearing completely from the scene is one of the hottest clues for Dyson spheres. Similarly, stars that are no longer used as power plants can suddenly reappear. To get to the bottom of Dyson spheres, scientists searched many other global data collections from the universe. Special attention was paid to techno-signatures that differed significantly from natural signals and structures, thus indicating the activity of extraterrestrial civilizations. Strange radio signals, unusually regular darkening rhythms, or phenomena in the spacetime structure for which there is no other explanation are the first indications of techno-signatures. The scientists found what they were looking for particularly in the extensive astronomical surveys of Gaia, Tumors, and WISE. These satellites collected countless amounts of information on millions of stars over many years. To cope with the immense flood of data, the researchers developed special data pipelines and filters to identify stars that show signs of techno-signatures. After the pipeline had filtered out the natural sources, a list of potential candidates remained. These were further investigated by looking at factors such as hydrogen alpha emissions, optical variability, and astrometry. Hydrogen alpha emissions are special light emissions that occur when electrons in hydrogen atoms fall from a higher energy state to a lower one. These emissions are typical for star-forming regions or active stars. The values help in the search for Dyson spheres. If no significant hydrogen alpha emissions are found, this may indicate that the observed infrared radiation does not originate from natural stellar processes but possibly from an artificial structure such as a Dyson sphere. Optical variabilities are simply changes in the brightness of a star over time. Natural causes of optical variability can be pulsating stars, binary star systems, or rotations. A Dyson sphere would affect the brightness of a star in a way that produces different frequencies than natural events. If optical variability is completely absent or unusual patterns appear, this is evidence of an artificial megastructure used to generate energy. Researchers use astrometry to measure the positions and movements of stars. If movements and anomalies are detected that cannot be explained by natural sources, they might indicate the presence of a Dyson sphere. The discovery of 7 stars showing signs of activity from advanced extraterrestrial civilizations is sensational news. These stars exhibit unusual infrared radiation that cannot be explained by any known natural phenomena, indicating the possible presence of Dyson spheres. After analyzing about 5 million stars, only 7 potential candidates were identified, making this discovery even more remarkable. These 7 stars, all M-dwarf stars, show clear excess radiation in the mid-infrared region. M-dwarf stars, which belong to the M spectral class, are the coolest and smallest stars in the main sequence. They have surface temperatures between 2400 and 3700 Kelvin and a brightness that is often just a fraction of that of the Sun. Despite their small size, with diameters around 20% to 70% of the Sun's diameter, M-dwarf stars have extremely long lifespans, often spanning several billion to trillion years. This longevity makes them ideal for the emergence and development of life and civilizations in their vicinity. Due to their long lifespan and moderate radiant power, M-dwarf stars could be the perfect long-term power plants for advanced civilizations. The James Webb Space Telescope, JWST, plays a crucial role in advancing the search for Dyson spheres. This telescope, with its high sensitivity to infrared radiation, is designed to measure such emissions as they are absorbed and radiated as heat by Dyson spheres. The JWST can scan the sky for the finest and most unusual infrared sources, collecting data on their intensity and spectrum. Any conspicuous infrared signal that cannot be explained by known astrophysical processes could indicate the presence of a Dyson sphere. Through comprehensive spectral analysis, scientists are obtaining more detailed information about these 7 stars and their surroundings. If a Dyson sphere is indeed present, the spectrum will show anomalies, such as specific infrared excess radiation. The JWST's MIRI instrument is capable of detecting large artificial light sources on exoplanets and filtering out artificially altered light from the natural light spectrum of a star. The telescope has already demonstrated its ability to gather an incredible wealth of data by detecting several biosignatures in the vicinity of the exoplanet K2-18b. This exoplanet, located about 124 light-years from Earth in the constellation Leo, has proven to be a promising target in the search for extraterrestrial life. K2-18b orbits the red dwarf star K2-18 and is within the habitable zone, meaning it could have liquid water on its surface, which is a prerequisite for the emergence of life. One of JWST's most remarkable discoveries on K2-18b is the presence of hydrogen and water vapor in the planet's atmosphere. Water is a crucial element for life, making this discovery of great significance. The telescope's ability to analyze in detail the atmosphere of such a distant planet represents an unprecedented scientific breakthrough. Additionally, JWST identified 4 gases that are unique biomarkers in the atmosphere of K2-18b. Biomarkers are chemical compounds associated with biological processes and can indicate the possibility of life. Among the most important biomarkers discovered is methane, which on Earth is primarily produced by biological activities, such as microbes and other living organisms. The discovery of methane in K2-18b's atmosphere could strongly indicate that biological processes are occurring there. Another significant biomarker detected in K2-18b's atmosphere is ammonia, which can be produced by biological or geochemical processes. The simultaneous presence of hydrogen, water vapor, methane, and ammonia paints a picture of a potentially living world. K2-18b is a Hycean water planet, a category statistically considered perfect for the formation of life. The possibility that K2-18b is a super-Earth, meaning it has a mass greater than Earth's but smaller than Neptune's, makes it particularly interesting. Super-Earths are common and could provide various environments that might support life. An important aspect of studying K2-18b is understanding how the chemical composition of its atmosphere remains stable over time and whether there are mechanisms that continuously replicate the observed biomarkers. Research is currently focused on determining the conditions on K2-18b's surface, such as whether there is an ocean of liquid water or geological activity that contributes to preserving the biomarkers. In a second round of observations, JWST aims to clarify further urgent questions. The first spectral analysis has shown scientists the way forward. They now know that they must continue to search explicitly for traces of life in K2-18b's vicinity. The observations of the JWST on K2-18b have provided the most detailed picture of an exoplanet ever obtained. What this telescope can achieve is truly incredible, and considering the feats it has accomplished around K2-18b, it is certain that JWST is also on the trail of Dyson spheres in space. The search for these advanced extraterrestrial structures continues to yield exciting results, promising more groundbreaking discoveries in the near future.